This is problem number 4 in section 10.1. The following table shows the Myers-Briggs personality preference and the area of study for a random sample of 519 college students. In the table, IN refers to introvert, intuitive. Introvert, intuitive. EN refers to extrovert, intuitive. I guess extrovert, intuitive. This is introvert, intuitive. IS refers to introvert, sensing, and ES refers to introvert for extrovert, sensing. All right, so we've got these Myers-Briggs preference types, and then we have, what do we have over here? Area of study. Okay, so what do we have? 1, 2, 3, 4 rows, 1, 2, 3 columns. We have a 4 by 3 matrix. Remember, columns, column totals and row totals don't count as a row or a column. Here's our directions. Use the chi-square test to determine if Myers-Briggs preference type is independent of the area of study at 0.05. All right, so first up, what is the level of significance? Well, I don't think we can miss that one. That's the 0.5. Tells us right here. And what are we testing here? Here's our null and alternate hypotheses. So what we're testing is Myers-Briggs preference type is independent of the area of study. So what do we have? Myers-Briggs and type of area are independent. That's possible. They're not independent. This looks right to me, but let's go on and make sure. They are not independent. No, they're independent. That's what they just told us, to test their independence. This is not independent again. This says that they are independent and they are independent. Okay, that makes no sense. So the only one that makes sense is this top one up here. And then we're asked to find the value of the chi-square statistic. All right, that's where we're going to go through the hypothesis test because it gives us all the information that we need. We're going to put our observed values into a matrix. So we need to access the matrix feature. So what you do is go to second on your TI-84, go to second. All right, down 1, 2, 3 keys, I think, to see x to the -1, the x inverse. But right above it is matrix. So second matrix, access that. And then what we want to do is go over to edit because we're going to input some data. So we're going to go over to edit. And now we have our choice with a lot of matrices. Number 1 is matrix A. Number 2, matrix B, ... I think I can see down to 7 where it says matrix G. Why don't we just select matrix A? So locate or get your cursor on A and just press number 1 or enter. All right, and now it's asking us for what size, right? So what comes up is this. It says matrix. All right, we've selected A, but it's asking us now for something by something. Now those somethings are the number of rows, the number of columns. Now up here, let's look at our picture here. Our picture has, actually they've colored it for us, but otherwise it's going to be 1, 2, 3, 4 rows and 1, 2, 3 columns. These totals don't count as a row or a column, nor do the headings. So we have 1, 2, 3 rows, 4 rows, 1, 2, 3, 4 rows, 1, 2, 3 columns. We have a 4 by 3 matrix. So we're going to enter 4, enter 3. So it's just 4, press enter, it'll jump over to the 3, 4, enter 3, and then press enter again. When you press enter again, you can see your 4 by 3 matrix. It shows up like this: 1, 2, 3, 4. The calculator doesn't do one big matrix, does 4 little ones. All right, so now we're just going to type in our data. So it starts right here. The cursor should be right here. And what we're going to put here is the entry in row 1, column 1. Right, so you're going to type 63, press enter. All right, so 63, enter. Now when you press enter, your cursor moves over here. right? And for that entry, we're going to type in the 12, right? We're just going to match what we see. So you type in a 12, and then when you do that, the cursor moves over here. And our entry here is going to be this 21, all right? So we'll put a 21 in there. All right, so why don't you just finish it off? So we press 21 and enter. So I'll read these off if you are trying to put them in as I do this. So it's an 85, enter, 44, enter, 25, enter, a 54, a 31, and a 30. And then the last row coming up, 75, 37, 42. And then way over on the right, just the way the calculator is built, you get the end of those rows. All right, so we've got our matrix in. Now, you want to be sure to press, after you get to that 42, make sure you press enter. And then we want to get out of the matrix editor. So you're going to do a second. And then right next to it is mode. If we don't get out of this matrix editor, sometimes it thinks that we're putting more data in. So you want second mode, and right above mode is quit. Right? So do a second quit. Now we're ready for our chi-square test. So this is going to be a regular hypothesis test. So we're going to go to Stat, over to Tests. Now, you have to scroll down quite a ways. If you look for all your tests, we're going to go all the way down to item C, and C says chi-square test. Now D, right below it, we got to be a little bit careful. D, there's another chi-square test. This is a chi-square goodness of fit test. We'll use that one in the next section. All right, but right now, get your cursor on C and select C. All right, so we will select C, chi-square test. Now what comes up? Not much. What comes up is observed. Now what's this expecting is into what matrix do we put our observations, our observed values? And then it's going to say expected. So where do we want to store the expected values, and then the expected values of our observations, and then it's going to say calculate. Now we put all our observations into matrix A. So we need to say matrix A here, and here's how you're going to get it. You're going to go to second, and then you want matrix A, so you go to that x to the -1 key again where it says matrix. But now you don't go to edit, you don't go to calc, you just press number 1, okay? Number 1, matrix A. It's like a cut and paste, all right? So you go to, you want your cursor right here, go to second, matrix, select number 1, and that should be pasted in. Now, if you watched the video or read the instructions out of the textbook on how to get these expected values, the expected values, right, we have this big matrix here. You know what? I'm gonna be right up here at the top. I'm looking here. All right? So for these, what is expected here? This is what we observe. How many do we expect here? All right, well, the expected for this, I'm just going to do this one, because the calculator is going to do it all for us. So just for this one right here, the expected number is taken by this. It's the total in the row times the total in the column divided by the sample size. So for us, that's going to be, all right, the total in the row. The total in the row. We're dealing with this one. Total in that row is 96. So down here, we're going to have a 96 times the total in the column. Now that column is 277 divided by the sample size. And the sample size of the grand total is at 519 right here. All right, 519. All right, so you make that computation, and I got 51.24. All right, so what we're doing is we are observing 63, and if things truly are independent, we would expect out of a sample size of 519 to see 51.24. Now, we have to do that. The chi-square test involves doing this here, for every one of these cells. So we have a 4 by 3, so there's 12. We'd have to get the expected value for all 12 of those, doing this, right? A lot of arithmetic. But the calculator does it for us. We just have to tell it where to store. So we're going to store it into B. But see, what we're doing here is we're comparing the chi-square compares the observed value to what we expect. And if that difference is significant, we're going to reject the claim that what? That preference and, what is this? Preference and area of study are independent. If the difference is not so big, we won't reject it. But let's get our expected values into a matrix. Why don't we put them into B? All right, so we'll store these into B. So what I want here is I want a matrix B right here. And I'm going to get it by pressing, just like we did before, second, x to the negative 1, which is the matrix key. And then I'll select number 2, which is matrix B. Right, so it's a cut and paste. So I've got the observed into A, the expected. The calculator will do all these computations, store all those values into matrix B automatically for us. Let's just go to calculate, press enter. Now, if you actually did that computation, you're out of the matrix now. So you have to go back into stat, tests, down to chi-square test. All right, and then we're going to calculate. Now, here's what I got. I got the chi-square star value, my computed value being 16.24, what is it, 2488. We're asked to round off to 3 places. How about 16.249? Okay, and actually, that's what they're asking for here. Find the value of the chi-square statistic. Okay, so we just found that. So I'm going to take this value here and put it right here. All right, so the chi-square test statistic value is, oh, I guess I don't need that. I'll just write the number, 16.249. Now, the next thing that comes up is the p-value, 0.01247. Okay, and then degrees of freedom. All right, so what is the question we're being asked here? Down here now, it says, are all the expected frequencies greater than 5? You know, I've written this down. Let's just check this. I'll show you how to check this. What you have to have are all these expected frequencies. All 12 of those have to be greater than 5. So they're all in matrix B. So all we have to do is call up matrix B. So let's check it now. So here's what we'll do. We'll just go to second, x to the negative 1, which is the matrix key. And now we're going to stay right on matrix and just choose number 1. No, not number 1, number 2. We put our expected into matrix 2. So just select 2. Now I'll do a 2 here. So I'm going to go to second, x to the negative 1, and select number 2. So what comes up is B. Now press enter. You press enter, and matrix B shows up. Right now there's a bunch of decimals here, so it's really hard to see. You'd have to use the scroll feature. All right, but if you use scroll, you'll see that every one of those values is bigger than 5. Right, my first one is 51 point something, and then 82 point something, and so on. All right, they're all bigger than 5. So we're going to check this off. Are they all bigger than 5? Yes. Next question. What sampling distribution will we use? Well, this is pretty obvious. I mean, they told us right up here to use a chi-square test. All right, that's what we've been doing. So we're going to use a chi-square. What are the degrees of freedom? Well, the calculator told us it was 6. Now, the degrees of freedom you get by doing this. Degrees of freedom is equal to the number of rows times the number of columns. Not quite. It's the number of rows minus 1 times the number of columns minus 1. Now we have 4 rows minus 1, 3 columns minus 1, so we have 3 times 2. That's where the 6 comes from. The next question down here is estimate our p-value. All right, so what's our p-value here? Our p-value that we computed is right here, 0.01. That's about 1.2%. Okay, 1.2%. So let's find that down here, all right? So let's find it down here. This is 5% to 10%. All right, we're at, what, 1%. All right, this is 1% to 2.5%. All right, I think that's where we are here, right? This is 0.5%. So we're at a little bit more than 1%. So 1% to 2.5%. So we are right here. Let's select that one. Question D says, based on our answers, are we going to reject or fail to reject? All right, this is where we come in to use our alpha. Now, I always do it like this. I got a P and an alpha. I'm going to compare. Now, P, I just have to go back a page. Watch your eyes here. 0.0124 or 125. Not that it's going to matter. 0.0125 if I round off. Alpha. Oh, I forgot what they wanted alpha. Now, I got to go back and get it. Alpha. Oh, 0.05. All right, they want this at 0.05. So let's go back up and we will claim that this is 0.05. Now, this is about 1.25%. This is 5%. This is less, right? So if it's less, right, if it's less than, I fail. No, I don't. If it's less than, I'm trying to think of all the possibilities, I reject H naught. So I'm going to reject H naught. Now, let's go back. Well, okay, that's good enough. I'm going to reject H naught. So what does it say over here? We're going to reject H naught at 0.05. So over here, which one are we going to use now? The top one says at P being, since P is greater than alpha, it's not greater than alpha. So it's not this one, it's not this one. P is less than alpha, so we're going to reject the null hypothesis. This is the one we want. If it's less than alpha, we reject. So I'm going to claim it's this one here. Now this question here says interpret. All right, what are we going to do here? So we are rejecting H naught. Now H naught, let's just go back to H naught. I'll go back to that page. H naught right here says that they are independent. We're rejecting this. We're going to go with that they are not independent, that there's some kind of relationship there. All right, so we're rejecting the claim that they are independent. Let's go back here now. So we are rejecting, in fact, I'm going to write it right here. I'm rejecting independence. Okay, I'm going to reject that. Now, I have to just decide which one of these matches my conclusion here. So the first one says, at 05, there is sufficient evidence to conclude that Myers-Briggs types and area of study are not independent. All right, we're rejecting that they are independent, so we're going to go with the claim that they're not independent. So that looks good. Let's just see what this says. At 05, there is insufficient evidence to conclude that they're not. Okay, well, there is sufficient evidence. We're rejecting H naught. You only reject if you have sufficient evidence. All right, so we have enough evidence to reject the claim. So we're going to go with this top one right here. If I can get it to right, there we go. So at 05, there is sufficient evidence. We have enough evidence to conclude that area of study and your Myers-Briggs personality type are not independent.